morning, everyone, and welcome to the OpenShift coffee break session today. Good morning. Ciao, Gabriele.
Ciao,
Welcome.
Fabio. Thank you.
How are you?
I'm good. Thanks. And thanks for having me. And hi, everyone.
Thanks for being here, and thanks to all the attendees we will have soon. I do have my coffee. I forgot to ask you to bring
I
for
already have it. Yeah, I already had it. Yeah, sorry.
There is always good opportunities to have the coffee. And let's start with the usual question. First of all, a brief presentation from you, Gabriele.
Yeah,
who you are, the company, where you come from.
I don't know. I have a slide. I don't know if you want me to show that. Otherwise, I can skip it later. But yeah, I'm Gabriele Bartolini. I'm VP of Cloud Native at EDB. So, previously, I can say that I kind of feel like I founded this company as well, because my previous company was called Second Quadrant, and it was acquired by EDB 2.5 years ago. And Second Quadrant was started in 2008. And I had already been using Postgres for many years, and Postgres has been my passion since probably the early 2000, when I was studying statistics at the University of Florence. And I was fascinated by data warehousing, data mining, and that's how I came to Postgres.
So we can tell you're a very experienced guy.
Yeah, so yeah, but I don't know. Yeah.
Let's say that.
There's always so much stuff to learn. I always say that every time I open the PostgreSQL manual, I find so many things I didn't know. But yeah, I also wrote a book about Postgres, the second edition of the Postgres admin cookbook. And yeah, so I pretty much started to participate to the community as a contributor. Basically, around 2006, I wanted to promote Postgres in the Italian public administration, and I tried to organize an event in Italy. Actually, Josh Berkus, who works for Red Hat now, he was part of the core team of Postgres back then, and he helped me organize this event in my city, Prato, which is north of Tuscany. And it was the first, let's say, large gathering of the Postgres community in Europe. And that's, I think, where everything started for me. I started to realize that there was, potential for a market of Postgres in Italy, and that's how Second Quadrant was born.
I also interesting.
Co-founded Postgres Europe, which is a non-profit organization that promotes Postgres.
May I ask you some few details about the open source project you mentioned in the slide, which is Barman?
Yeah. Yeah, basically.
Where the name for an open source project?
So Barman is actually, at the time, we were helping customers move from Oracle to Postgres. Okay, and in Oracle, there's a tool called RMAN, which is Recovery Manager. And in that period, Postgres had a solid framework for business continuity, and especially continuous backup and point-in-time recovery. But what we were used to see at the time were many custom scripts. So everyone was using their own, custom scripts to perform backups and recovery. And we came up with the idea of having a Python tool that was able to manage remotely backups and also the recovery part. And that's how Barman came, and then because I don't take myself too seriously, very often we came with the name Barman, Backup and Recovery Manager for Postgres.
Okay, cool.
That was probably the first, let's say, dedicated tool for backup and recovery in Postgres, and it's one of the most used.
Okay, so we started with the why, and now let's move forward with the what. Sorry, with the who, and let's move to the why, which is the reason why you are here today. I know the story, but let's share it with the wide audience.
Yeah, I think I'm here to actually that's pretty much the work I've been doing the last 4 years. Is to I kind of reinvented myself in the Kubernetes space. Okay, because I've been fascinated by DevOps movement for many years, and all the automation, continuous delivery, all those principles led us to Kubernetes. And we came to the idea, why not using Kubernetes for Postgres as well? And our concept to bring Postgres into Kubernetes was born in 2019. I think after we realized that local persistent volumes were kind of solid in the Kubernetes space, and also the operator pattern was becoming dominant. Okay, that's when we said, okay, let's see if it's possible. And what we did back then was to actually try and install Postgres in Kubernetes on bare metal and see how it would perform, so with a kind of a fail fast approach. And we saw that it was actually going pretty much as fast as bare metal. And that's when we said, okay, that's it. Let's move forward. And that's how our operator was born. And in 2022, this operator, Cloud Native PG, was released open source. And yeah, here we are, and then Cloud Native PG, we've got an operator for also for OpenShift. And I will be talking about that today. So.
Okay, so let's move to the next phase.
Yes.
So the what. Do you have because I said, okay, we have a slide deck.
Yeah, so basically we're talking about Postgres. I think Postgres is one of the most used databases in the world, and it's never too old. So it's been innovated for over 25 years. Now there's version 15, version 16 will be coming out in a few months. It's open source. It's a multi-purpose database. It's very solid. The architecture is one primary and multiple replicas, which I think basically you can scale vertically with very high number of transactions per second. Then stream replication, physical replication, synchronous replication as well, which can be controlled at transaction time. So you can say this transaction is very important. I want this to be written also on another host, or this one is less important. Just write it here locally. There's continuous backup, point-in-time recovery, declarative partitioning. So anyway, there's so many features with Postgres that I think, as I always say, it's probably worth to I think start a kind of a blog series about these very important features that Postgres already has for the new generations that are maybe approaching Kubernetes now and maybe are less familiar with the SQL standard, which is, in my opinion, a very underestimated language. So yeah, this is Postgres, and in one slide it's kind of difficult, to recap. Then this is EDB. So I like to share this. I don't want to promote, use this space to promote the organization too much, but I think this is worth more than 1,000 words. I think EDB mission is to bring to innovate through Postgres. And if you follow this link, you'll see there's actually a very nice infographic that shows all the contributions to the open source Postgres done by EDB in the last 15 years. And you'll see, the mission of our organization is to really improve Postgres over time. Yeah.
Gabriele, may I ask you, because you mentioned in this article that Fortune 50 banks are leaving the let's say
Oracle.
Old Oracle,
Yeah.
let's name it, and to go on EDB Postgres. you have some info or more details about the use cases usually
Yeah,
in
of course.
the banks? So online, I don't know, online banking, payments, or vertical. Also, please, yes.
Yeah.
I'm
So
pretty curious
basically,
about that.
Oracle migrations is one of the key differentiators of EDB. So it's normally, you know, I like to define it also as a cultural change in an organization. So of course, you need also training for Postgres, because Postgres does things in a different way. But EDB has a layer of compatibility with Oracle, and also a set of tools, practices, and skills that help you migrate migrate to Postgres, also using semi-automated and automated tools. So it's a very important part of our business, and this is also available in our operator. So in our operator, you have access to EDB Postgres Advanced. EDB Postgres Advanced is a fork of Postgres that introduces an Oracle compatibility layer inside, so you can migrate more easily your databases from Oracle to Postgres with this layer, while maybe you start, you know, your new applications in Postgres. So you actually see this mix of use cases. So, you know, new applications in Postgres, while we also maybe keep also legacy systems and don't migrate, or others are migrated using the compatibility layer. And the good thing about EDB is that it provides assistance through all these phases, you know, as well as being influential in the open source products that now include also the operator for Postgres.
Okay.
So I hope that helps.
Definitely.
Yeah, thanks, Fabio, for the question. And you know, this is an article that I wrote last year. It was very popular, and this explains why I think it's important to run Postgres. So if you run Postgres in Kubernetes, so if you have a few minutes, you know, it's worth reading, so you understand more.
Definitely.
And this is also a very important movement, which I'm really proud to say that we have contributed to this from the start, is the Data on Kubernetes community. And the Data on Kubernetes community aims to promote the usage of data workloads in Kubernetes. So again, you can follow this link. You find a report that actually says that having data workloads in Kubernetes actually increases the productivity. So it's an independent report. And
well, when you say that data on Kubernetes increase productivity, what do you mean?
I mean, having data workloads alongside applications in Kubernetes. Okay, so because many times we see that, for example, database is left outside Kubernetes. Okay, so with this community, we are working very closely with the SIG storage and text storage, which at the moment are the most similar groups of interest inside the CNCF that talk about databases and data workloads in general, to bring awareness, to increase awareness about using Kubernetes to run data workloads like databases and Postgres, for example. So that's because still the perception is that you cannot run databases in Kubernetes, which is due to the fact that Kubernetes was born as a stateless application system.
Platform as a, yeah. And do you think also that also in terms of operation, there are increase of productivity? So operate database on Kubernetes provide some help or improve the way the operations or people managing operation do it usually when they manage the same data framework outside Kubernetes?
Yeah, I believe so, because in general with Kubernetes we are managing something complex. You know, we're not managing, you know, machines. We're managing infrastructure. We're managing data centers essentially. So with Kubernetes, the opportunity is to move down the complexity and the risks of, for example, operational disruptions down to the infrastructure level, so that we can exploit Kubernetes to self-heal, to manage high availability at the application layer. And a database in Kubernetes is an application. So if you think about that, what we have done with the operator is essentially put all our experience, so 20 plus years experience on how to manage Postgres in business continuity, in mission critical environments, but people that have written high availability tools, failover management tools, backup tools, and have been managing Postgres with some of the largest customers in the world directly into the operator. So for example, if there's a failure on the primary, we have developed this logic inside the operator to do the right things with Postgres and make sure that we are failing over in a fast way. And if the primary comes back up, to try and realign by using, for example, PG rewind in case the primary had gone forward in the timeline. So all of these, basically all the stuff that could be automated have been put into the database, into the operator. So the database administrators, in my opinion, and that's what I always say when I talk about reshaping the DBA role, is that in my opinion, it's more elevated. So DBAs will be used for the stuff that requires more thinking, and where I think human skills can excel and can make a difference, instead of the automated stuff that we were used to for many years, to the point that it kind of became the task that were always referred to a DBA profile.
Okay.
So I think it's going to improve. I think a lot of these managerial stuff. And the other thing, for example, for a failover, DBAs and sysadmins will stop being paged overnight because database was down or there was a split brain, for example.
Yeah, the usual nightmare of DBA.
Yeah. So I think it's important.
Okay, perfect. Cool.
Thanks. So to recap, I think to run Postgres in Kubernetes, you need to know Postgres, you need to know Kubernetes. So without these, it's not like fairy tale.
To this point, how much need of how much knowledge of about Kubernetes a Postgres developer? Let's speak now to developer needs to have.
I think my last point. So this is also, I think you also need to have a good operator. But more important, when I say you, I like to talk about kind of DevOps multidisciplinary team. So that's again the DBA role reshaped, in my opinion, needs to be part of a like a T profile person that works with other T profile developers in a multidisciplinary team, so that this person can help the developers with SQL. But if you read my article about why running Postgres in Kubernetes, I think we've got the opportunity here to put the database inside the continuous delivery pipelines, so that, for example, the developer writes their applications, and they have the database inside, and they run migrations as part of the unit test, and also the end-to-end test using kind on their machines. And when they pass, they push them. And then before that branch is merged into main, we put some gates that require further end-to-end tests to pass before the patch is merged. And that's how we ensure continuous delivery, which then enables us to deploy continuously, and, for example, have an application that can deploy in a very fast way new features from the developer to the consumer. And that's the goal of this. And the database was, I think, left outside, and now I think with our operator, the chances to have it inside are increased.
Yeah, right. That was, you anticipated my question: how complex or how easier you see the CI/CD procedures with Postgres. I mean, you are deploying modification, something new or new capability in the application. That means probably something new or a different data model. Usually this creates a lot of pain when you need to deploy this in production. I suppose with Postgres and the overall capability you explained before, the easier way to avoid these pains probably.
Yeah, I think there's one cool feature of Postgres is called transactional DDL, which is something that when we showed it sometimes to Oracle people, they kind of freak out. But basically, you can create stuff and then roll back. Okay, so that's what you can add columns, you can and then roll back. So this is a migration. So the migration can be atomic. So that's the good thing about Postgres is that. And the other good thing is that you actually make the developer responsible for this part. So the idea of the microservice database has been at the foundation of our operators since day one. So we want to have a database that is owned by a single application and by a development team that is independent. Okay, so forget about the monolithic database, where there's the DBA, you need to make a change, you need to change version, you need to wait for other tenants to move. This is all independent. So there's a highway between the developer and the production system, and that's where I think Kubernetes excels. That's I think where that the real benefits that Kubernetes is bringing is decades of innovations, not only in technology but also I think in how people in IT work together. That's I think what fascinates me the most.
I agree with this. Very, it would take probably more than 1 hour.
Yeah, exactly.
But anyway, if you want to use Kubernetes with the old procedures, old methodologies, you probably are going to fail soon. If you want to adopt Kubernetes, you need to disrupt all the process you use usually to put in production, or starting from the source code to the production phase, so including also the database. Definitely, yes. Okay, cool, interesting, really.
So like here we go with Cloud Native PG. It's a level 5 production ready. So it's been used in production for a few years, and it's open source. It's Apache license 2.0. But I want to, say that EDB last year in April, basically April-May, donated the IP, so the intellectual property, to this community. So the mission, the idea of EDB was to try and pursue the CNCF sandbox, which we actually tried last year. The project was rejected. We're going to retry. So the idea is to donate this project to the CNCF, but at the moment it's governed by the Cloud Native PG community, and so there's an open governance model, so everyone can participate. So it's not owned by EDB, but EDB actually pays us to contribute to this software very heavily. So this is
the usual model.
Exactly. So, and that's why I'm really proud to be part of EDB. Because this is a company that combines both open source and proprietary software for sustainability. The important thing of Cloud Native PG is that we don't use a failover management tool. So, for example, we don't use patroning, and we don't use stateful sets. So we have basically extended the Kubernetes controller. So the operator is written in Go, and we take full control of Postgres and the persistent volumes. So we manage actually the PVCs directly. So it's a very interesting model. It's all explained why we did this in the documentation. So if you're interested. So then another very important approach is that we are using immutable application containers. So the containers run only one application, which is the instance manager, and it's a Go application that we have written, which control Postgres, and they're immutable, so they're read-only. So that's why, for example, we support restricted SEC version 2 in OpenShift. Okay, so this is very important, and it's fully declarative. So support convention over configuration. So we have defaults. So you can override pretty much every attribute, but we have defaults that work for most of the cases. Then, yeah, we made automated failover. We provide services directly. We have mutual TLS, so security by default. So we build a CA by default for each cluster, and we create TLS certificates to communicate with the replicas, so no passwords and so on. You can integrate with Cert Manager. We manage affinity control, then rolling updates. So when you update the operator or the operands, we restart the standbys first, and then we allow you to choose the method to restart the primary, or, for example, switch over first before you update.
Okay.
So there's, interesting things, and I want to share how the product is actually, the project is going very well on GitHub. If you are, following us now, I wouldn't mind if you can add a star if you haven't done it yet. We have over 1,200 stars in less than 1 year, so the project is going very well. So
skyrocketed, yeah.
Yeah, I'm very proud about the team, what the team's done. So, but yeah, so the Cloud Native PG is the open source project, so it's the foundation. But today I'll be talking about EDB Postgres for Kubernetes. I am talking about EDB Postgres for Kubernetes. So it's a fork essentially of Cloud Native PG, and it was actually the father, because everything started as EDB Postgres for Kubernetes, or Cloud Native Postgres as we used to call it. Then we open sourced it in April last year, and since then we have forked EDB Postgres for Kubernetes on top of Cloud Native PG. And so this explains why we have more than 2,000 commits and why it's been used in production by large customers. And for OpenShift, we have a certified operator, and we also provide long-term support. And we are improving the backup strategies with Velero or OADP. And also we are talking with Kasten about having this transparent support. So essentially what we do, we take cold backups of the standbys in a transparent way. So if you issue a Kasten backup or a Velero backup, what happens is we stop a standby, we take a snapshot, and we restart it so the primary doesn't even see it. And for recovery, we use that to restart. These are the links if you're interested, and this is the page for the operator in the certified operator in Kubernetes. By the way, yesterday we released version 120 of the operator. So briefly, to deploy a 3-node high availability cluster with our operator. So normally what you would do outside Kubernetes is you install the latest Postgres 15 miner, you created first the primary, and then you create the standbys, the 2 standbys. But with the operator, what we do is we also set up mutual TLS between the replicas. We use replication slots, and for example, we can set resources and so on, and create a user and a database for the application. And we also provide a way to reliably access the database via the network. And this is the manifest. The manifest is very simple. So in this case, we use cluster is the kind, so it's the resource that we have created. Then we give a name to the database. We call it myAppDB. In this case, I'm using the guaranteed quality of service by setting requests and limits to the same values of 4 gigabytes and 8 CPUs. Then I create 3 instances, meaning 1 primary and 2 standbys, and I request to have at least one synchronous standby at any time. Then I request to enable replication slots. If you're not familiar with Postgres, that's fine, but replication slots are a way to keep the synchronization between the primary and the standbys, so the primary knows what world files to maintain for each standby. And following a failover, they actually persist with our operator. So the standby, which becomes the new primary, knows where the other standby was left. Okay, so this is a cool feature of the operator that is available for everyone. Then we can specify the storage for the PG data, and the world files are the transactional log. And yeah, and this is what happens. So this is how you apply the manifest. And this is what happens under the hood. The operator creates the PVC for the PG data and the world, then starts the pod, creates the service, waits for the primary to start, and then enables applications from this moment on to connect to the primary. Then clones the standby by creating the PVCs first, starts the pod, and begins streaming replication with mutual TLS, and then creates also a read-only service that points to the standby, then creates the second standby, and so on.
Yeah, Gabriele, question, you are mentioning here availability zone.
Yeah.
If I'm not wrong, are there specific requirements for the network latency between the availability zone, or the usual ones that
yeah, the usual ones, so theoretically within the region, we're talking about the same region here, so at least two in the order, I would say, below 3 milliseconds, and the third one below 5, let's say. But still, in the same, we're talking about a cluster in the same city. I didn't add any slides about the architectures here, because that's also complete, a large topic. And in any case, I've got more slides here. I will leave them here. I won't be able to cover all of them, but essentially, yeah, our approach is to have at least 3 availability zones in each Kubernetes cluster, which I understand that on-premise that's not always the case, unfortunately, but I think we'll get there. This is still, I think, reminiscence of lift and shift approach from the old VM stuff. So we ideally soon we'll have more 3-zone Kubernetes clusters so that we can leverage self-healing. Yeah, but that's it. So I want to briefly show how the failover works. So suppose we've got a problem on the primary, the service is detached, so there's actually a downtime for the application. So applications that are, all the active connections and queries will be canceled. The standby is promoted as primary, and the service is restored. And the standby starts streaming from the new primary. And when the old primary pod comes back up, it's resynchronized. And this is all done transparently by the operator. Tell me about the time, Fabio.
We do have still 25 minutes.
Okay.
So how much time do you need for the demo?
10? Yeah, 5-10 minutes. Yeah. So
I will call time at 45. Yeah.
But briefly, storage for us, being a database, it's the most important
obviously
part, So, but the good thing about the operator is that we delegate everything to the storage class. So we support dynamic provisioning only. We don't support static provisioning. But as you know, if you've got storage classes, and Kubernetes, you can do that with them in any case. So. So you can use local storage, which is our, recommendation for the highest predictability and performance, or you can use network storage. Okay. I have, the two extremes in a single cluster. So for example, you can use Postgres with our operator in this case. So you've got shared storage and shared workloads. So you put databases in the same nodes where applications are, it's a mix of everything, and it works fine as long as you're happy with the expectations, that that you get when running a database in this scenario, but it works fine. And this is, I think, what we would like to see more in a non-prem, especially on non-prem environment. So, and that's the other hand, sorry. So you can have all the possibilities in between, is to have actually a dedicated node with dedicated storage for a single database. Okay, that's where I think the high-end users, or for example, the banks that are moving their databases from where it is now into an environment like OpenShift, they have this possibility. And with Kubernetes, it's pretty simple because you've got taints. So you put taints on nodes, and you say only Postgres can run on these nodes, and or you can use the node selector to actually put a specific database on a specific set of nodes, maybe in different availability zones, so that you've got one in primary in one availability zone and the other standbys in the other two. And for example, you can even say that I want the synchronous to be in these two availability zones, for example. So this is, I think, the most extreme case, which is possible. For example, a very good compromise is to dedicate, let's say, start with 3 nodes dedicated to Postgres with local storage, 1 in each availability zone, and say all the Postgres workloads go into these machines. Okay, so applications are in the same Kubernetes or OpenShift cluster, but databases are in different nodes.
Okay, so you can have a dedicate
hybrid,
you can dedicate different kinds of resources.
Correct. And this is, I think, a very good compromise, I think. And you get all the benefits of running Postgres in Kubernetes. So you've got a kind of a native, Kubernetes native and cloud native, combo application and database. So I don't know. I'll quickly go through these. So our operator gives you 3 ways to bootstrap. One is the initdb. So initdb, you create a cluster from scratch, and it's also the method that we use to perform import of existing databases, or also at the moment migration from an older version of Postgres using logical import. So right now it's possible, for example, to have a database on RDS, let's say, and move it in OpenShift with our operator using the import facility. So you just connect with a super user account to the RDS, for example, database, and you create a new database on Postgres 15, with just one configuration file. Or you can use the recovery one, which is used to create a replica cluster, for example, and to issue point-in-time recovery. For example, you've got a table that was deleted at 10:30 this morning, and you want to restore the database up to that point. If you've got continuous backup, you can use it with the bootstrap recovery method and put a target with a timestamp. This is the article I was, in which I explained how to use the import facility, and it's quite complex. It's the import facility. It's quite complete, I would say, but it's all documented. The rolling updates. So it's essentially the way for us to also upgrade Postgres, a minor update of Postgres. So every time we change the operand images, so if there's a new minor version of Postgres, or if there are vulnerabilities that have been fixed, we build a new image every day as a community and as EDB of Postgres. So every day, if there's a library that has changed, the UBI image that has changed, or a new version of Postgres that has been released, we create a new image. And so when you do that, when you update the operator, or when you change some values in the configuration of Postgres that require a restart, the rolling update is triggered. Backup and recovery, at the moment we support only S3, and as I said before, Kasten and OADP. I mean, Kasten is on the way, but OADP or OpenShift for snapshots.
Okay.
But the native backup and recovery stuff for Postgres is available only on object stores. And so, for example, you can use ODF with the object store for these, and then maybe relay on the cloud or directly in the cloud. For monitoring, we've got a native Prometheus exporter. So by default, we provide some standard metrics, but also allow you to configure, your custom metrics directly with configuration. So with a config map or a secret, and that's neat. And as far as logging is concerned, we log everything to standard output, so you don't need to install anything inside the containers. Basically, we export directly in JSON in standard output for all the applications and all the applications we run. We also have PG audit support, and for EDB audit. So if you need auditing, that can be enabled. Yeah, Fabio.
Yeah, my question is more about sensitive, probably something that you will explain later. I don't remember if it's in the presentation. If Postgres provides any specific capabilities when you have to deal with very sensitive data, or just rely more on the application.
I mean, there's work to be done in transparent colon encryption, for example.
Okay.
To do that, EDB has got transparent data encryption support for EPAS 15. So if you want, basically the data on disk at rest is encrypted. Whereas at the moment, normally until EPAS 15 or with Postgres, what you do, you encrypt at the storage class level. Okay, so in terms of protection, there's all the DCL stuff, from SQL. So you can create roles that can only access some columns and so on. So it's all done by that, So, but yeah, there's work to be done on the transparent column encryption, for example, to enable encryption even at runtime,
Okay, I think it's probably time to go to the demo. It's time 45. So what do you think?
Yeah. I've got one slide. I think it's cool. We've got a plugin. It's called CMP. So it's a plugin for kubectl. And
anyway, it seems, sorry for interrupting, it seems that you have a great fan in among the attendees. Jonathan Gonzalez saying grande, which means great in Italian.
He's a fan.
Okay.
Jonathan is part of the team, so he's
also Paul Lees. Okay.
Yeah, no, police. No, I don't know. Hi, Paul. Yeah. Okay, so
let's go to
so the demo. Yeah. By the way, I think Jonathan would have been much better than me to do the demo, given that he's.
We can host him next time.
Yeah, exactly.
You're welcome, Jonathan.
Ciao, Jonathan. Okay, so So
can
essentially,
you just please enlarge it just a little bit. Okay, perfect. Okay, cool.
Okay, so this is I already installed the operator before, but it's pretty straightforward. Okay, so you go on Operator Hub, you type EDB, and there's our operator. Sorry, I've got the other screen there, so I'll look here.
No worries.
So 120 was released yesterday. This is the page. You click install. Now it's already installed to speed up things. And if you go here, So this is a brand new OpenShift cluster. I'm not an OpenShift expert. Okay, it's really difficult to talk about Postgres in general. I'm trying to bridge the gap between these two worlds.
You're not taking a Red Hat certification, so
no, I want to. So this is the operator. We provide these 4 CRDs. So backups, puller, scheduled backups, but the most important one, which I will cover here, is the cluster. Okay, so I think I created a cluster in the Postgres namespace, called GB. Let's create another one, okay, just to show
how easy it is to do.
Yeah. So
and obviously, let's remind attendees whatever you are doing through the user interface can be automated, obviously with OCI command line.
So let's call it Fabio. Okay. So we create a new cluster called Fabio. We can add all the labels here. Here we say, okay, let's create with just 2 instances. Okay. Then you can provide pool secrets. For example, in some cases, we've got customers that maybe also run these in a air-gapped system. They need to change the image name. So all of this is possible. Okay, and if they want, they can put them in private registries. Because when I was talking about the immutable application container before, we provided a set of requirements for the images, but basically what you can do is also you can create your own images and add, for example, your custom extensions and so on, and then put them in a private registry for some selected customers. Okay, and provide a way to specify the full secret. Storage, this is the storage for PG data. So let's say I want, I don't know, 20 gigabytes. So this is primarily it's called PG data. It's the main directory of Postgres. And I think since version 116 or 17, I don't remember, we added the separate volume for vaults. So wall files are the transactional logs. So if we store them in 2 different volumes, we can actually parallelize operations, so improve vertical performance of the database. And for example, you could use a different storage class. Okay, so this is also an interesting approach.
Feature, yeah.
And we will add table spaces in the future here, so with the same mechanism. And for example, I would like to explore LVM. I know that Red Hat OpenShift has introduced support for LVM, I think from version 4.12. And I think this could be cool to actually test these, especially if we're going towards volume snapshots support, Kubernetes volume snapshot support. So it means that, for example, with LVM, we could use LVM snapshot to perform incremental and differential backups of the volumes. Okay, so I think this is an interesting area for improvement. Then here you can specify the resources. For example, you can put cores, memory. Here you can specify the object store. For example, you could put the S3 compatible object, so you can define it here, so that the wall files are archived here, and also the base backups are stored here. The base backups are these let's say physical copies of the data directories. Okay. Then we've got replication slots. I enable them. So basically, I want replication slots to be also failed over in case there's the primary goes down. Then I think we're fine. So I hit create, and the Fabio cluster is is being created. Let me see if I.
So the resources, okay.
Let me see if I can share the screen. Okay, I don't know if you can see. Okay.
Yep, I can.
Sorry, OG.
Can you just put the little bit bigger?
Yeah.
Okay. Okay. So
okay, so we see that the first one is already running, and now we are creating the first standby, because we just wanted one. Okay. So essentially, the join method, what it does, we have the new PVC, and we initialize it by running a PG-based backup from the primary, so copying, cloning essentially the data directory, and then preparing it for the new pod to be started as Postgres. And yeah, this is running now. So I don't see anything. Okay. I can see the part. 1 second. Okay. So if I go back to sorry. 1 second. I apologize.
no worries at all. What they're looking for.
No, I think I closed all the. Yeah, I think I closed.
The user interface, the console, OpenShift.
Okay, here it is. Okay,
Yeah,
so we've got 2 instances. Okay, I could scale up. Let me find. Okay, so if I go here and I put 3. You see that it's scaling up, so the replica is being created. So now maybe what I can do is show, once it's aligned, maybe I could actually, let me see the plugin briefly. CMP plugin status. Let's see the cluster Fabio, how it's doing. Okay, so this is the plugin. This is very nice. We also export in other formats, but this tells you the version of Postgres you're running, Postgres 15.1. Again, convention of a configuration. You didn't specify anything. The operator sets the latest version of Postgres at the time the operator was released. The primary is 501. The cluster is in a healthy state. This tells you the LSN, the log sequence number in the PostgreSQL basically history. And these are the certificates that have been automatically created for you. Without doing anything out of the box, we have a let's say, a separate CA for that specific cluster, which is created by using the CA that we generate when the operator is installed.
Cool.
Okay.
Yeah, definitely. So, sorry, Gabriele, for interrupting you, but probably before leaving the session, there is a question from Paul Lees.
Okay, yeah.
Gabriele, please, could you provide some more details about the EDB additional layer for the migration from Oracle DB?
You mean information about where to? I mean, I can tell you the where to find information on the website, or if you want, you can reach out to me after. But essentially, it's it's part of EDB Postgres Advanced Server. So it provides, for example, support for some libraries that are exist in Oracle, and they have been made available also in EPAS. I'm not the best person to talk about these, you know. So I think if you're interested, but essentially, yeah, it facilitates the migration from the Oracle database. Yeah, I can give you, the link, I can pass it to you, Fabio, afterwards, and
or if you have it? No, probably not. So I don't think.
Yeah, I can. It should be available from the EDB website. Okay.
Website. Okay.
Yeah, definitely it's there. So let me. So I wanted to try, if possible, to kill the primary. So let's try OC delete pod dash n Postgres Fabio 1. And this is what's happening. I think actually, if we look at the status, it's already been promoted. Yeah, you can see that the new primary is Fabio 2, and that was pretty much instantaneous, as you can see.
Yeah, definitely. Yeah, one more question from the audience. Vasco Rodriguez is asking if there are any CRDs for creating databases in the cluster.
Yeah. Okay, let me go here. So essentially, what we don't have that yet. Okay, and I don't think we'll use CRDs. I don't know if you saw. Let me go here. Cloud Native PG docs. We introduced in 120 support for role management, and so declarative role management. So this is, let me enlarge. This is our approach. So we allow you to specify in the configuration the roles you want to add to, or even, for example, if you ensure absent, that we remove those users. Okay, so we will add a manage databases section in the future. At the moment, we just create one database. It's the application database. So out of the box, when we create a PostgreSQL database with this operator, you have a database called by default app that is owned by the app user, so that your application can connect there. Yeah.
I hope, Vasco, this helped you. Can you please share in the chat, in private chat, the link so I can share it on the public chat?
So this is the open source
if you don't mind.
So I'll share it in the Okay. And
thanks to you, Vasco.
Did it answer, Vasco? Okay.
Let's say thank you. So it seems fine. And 11.
Yeah.
Time ran very, very fast. So time to close and say goodbye. To say goodbye, people, and to all our attendees. Gabriele, just closing words. First of all, thanks a lot for being here.
No, thank you for having me here, and thanks for this session. And it's good to to have these. I mean, I would like to work more closely with Red Hat in the future, and I think there's a lot of help that customers need in this area by both for example, EDB and Red Hat. So I see this from the market, and yeah, I'm glad I was able to talk about the operator here. So thanks for having me.
Definitely an interesting topic. So guys, see you soon in 2 weeks, as always. And again, thanks for joining, thanks for your time, and thanks for having your morning coffee with us. And as always, you can watch the recorded session on YouTube. Saying that, have a great day, and again, see you in 2 weeks. Cheers.
Yeah, thank you, Fab. Thank you, everyone.
See you soon.
Bye bye. Thank you.
Bye bye.